Hey everyone, today I am here to present you with a project called Detective Zero Day, and the objective of this project is to build an AI-based threat detection system to detect zero-day attacks. So a quick overview about what is a zero-day attack. A zero-day attack is basically a cyber attack that targets an unknown software vulnerability, and the vulnerability is exploited on the day it is found, hence giving the developer 0 days to be ready for the attack or patching up the vulnerability and avoiding it somehow. The traditional antivirus systems can only detect attacks that use already known signatures and are unable to detect zero-day attacks due to their unknown nature. So here we are utilizing machine learning algorithms that can capture any potential threats that exhibits anomalous behaviors and hence giving promising results for zero-day attack detections. And the idea here is to build an application to detect zero-day attacks. Our applications works by analyzing the network logs provided by the user. And here we employ two-layer classification systems to detect zero-day attacks efficiently. And the app also gives you a detailed report of the identified attack and the steps need to be taken to resolve it. And the machine learning models used in this project are the first one is LSTM, which is short for long short-term memory, which is a recurrent neural network, and the second one is isolation forest. These both models will be trained on the CIC IDS 2017 dataset, and the tool used to collect network logs will be CIC Flowmeter. And a small information about this: this application is intended for a security analyst, as he is well aware of the security terms and things about network traffic. We have left the job of collecting logs totally to the user, and we are not worried about it. And coming to the dataset, it contains several attacks such as DDoS, web attack, brute force, infiltration, bot, etc., and benign, meaning not an attack. So the preprocessing and EDA or cleaning the dataset will be done using pandas and label encoding, as you can see here, like removing the null values, duplicates, infinity values, and checking the correlations and etc. And finally, the clean data will be used to train the neural networks model LSTM. That will be done using TensorFlow. So here's how application works. Firstly, we'll be taking network logs of the user, which are collected using Flowmeter, and then the data will be passed to the first layer of the classification. Here in the first layer, we'll be doing a binary classification using LSTM model, meaning it would be predicting whether the data is malicious or totally benign. Here we can see 0 meaning benign and 1 meaning attack. And if the results seem to be malicious, then it will be passed to the second layer of the classification where isolation forest comes into play. And here's how it works. Let us consider an isolation forest model trained on a single class, a single attack, let's say DDoS for example. Then when we give data related to the DDoS attack, the data points would be plotted very near to each other as a cluster. These can be isolated very easily. But when we give data other than a DDoS attack, then the data points would be plotted very far from the cluster. We can consider these as outliers, and these can be isolated easily by drawing some geometrical lines. In this way, we can decide whether the attack belongs to a DDoS class or not. And in the similar way, we have created an isolation forest models for each of the attack, like DDoS, web attack, brute force, SQL injections, infiltrations, etc. By using these multiple isolation forests, we can differentiate between known attacks and unknown attacks. Coming to the known attacks, the user will be notified along with the suggestions, and unknown attacks, where the attack doesn't match with any of the attacks already in the dataset. These would be considered as a zero-day attack, and obviously the attack would be merged with the dataset, making it as an already known attack. Yeah, that's how it works. And coming to the machine learning part, we choose LSTM as our primary classifier because it works best with the sequential data, or you can say time series data, and can learn long-term dependencies and kind of can decide what to forget and what to remember to give the best predictions. the model's architecture of LSTM. And after a long training, here's the result where the false positives and false negatives are extremely low and the accuracy is high. And it works with the test. It works well with the test data as well. When we give the data set totally benign as a test data, we'll be getting very little amount of malicious prediction. Of course, everything can't be a false proof. And when we give the data totally malicious to the prediction, we'll be getting a little amount of benign thing, which is alright. And coming to our application, our application will be a web application which can be accessed anywhere in the world with an internet connection. And in the front end, we will be using React.js to develop the user interface. And the backend will be done using Fast API, TensorFlow, and Python, which will be convenient for doing the machine learning part. So coming to the prototype of the project, here we have a React front-end code which accepts an input type of file, CSV file obtained from the CSV flow meter, and posting it to the backend. In the backend, we are using Fast API, and the file from the front-end will be caught over here. We can see all the models loaded up over here and putting them in a loop. The next thing is predicting, and the prediction, the first layer seems to be not malicious. The attack type will be not available and it will return to the front end. But if the attack seems to be malicious, the prediction seems to be malicious, the next thing is the isolation forest comes into the play. Then the dataset will be predicting with each of the isolation forest models we created earlier, and the number of inlayers, I mean the matching samples of the attack. If the matching samples of the attack is more than 50% of the total number of records in the dataset, then the attack type will be finalized. Attack type will be finalized and returned to the front end. So let's try this out. Select the file, CS and CSV file with the malicious content, and ignore its loops as we are still in the development stage. Yeah. Here we can see the attack type is perfectly correct. Same, and we can see some information about it. Yeah, that's it for now. Thank you.